For the first time, scientists may have detected signs of a planet transiting a star outside of our galaxy. This detection, using NASA's Chandra X-ray Observatory, opens up a new window to search for exoplanets farther away than ever before. To be clear, while we have found planets around other stars within our own galaxy, all of these discoveries have been made within the Milky Way. This new discovery is based on the analysis of an X-ray binary system in the spiral galaxy Messier 51, also called the Whirlpool galaxy. And if confirmed, this would mean that this particular planet is located around 28 million light-years away. So this discovery would be thousands of times farther away than any exoplanet found in our galaxy so far. Exoplanets are defined as planets outside of our solar system. Until now, astronomers have found all other known exoplanets and exoplanet candidates in the Milky Way galaxy, almost all of them less than about 3,000 light-years from Earth. An exoplanet in M51 would be about 28 million light-years away, meaning it would be thousands of times farther away than those in the Milky Way. We are trying to open up a whole new arena for finding other worlds by searching for planet candidates at X-ray wavelengths, a strategy that makes it possible to discover them in other galaxies, said Roseanne D. Stefano of the Center for Astrophysics, Harvard and Smithsonian CFA in Cambridge, Massachusetts, who led the study, which was published today in Nature Astronomy. It's kind of like when Galileo turned his telescope to the sky and saw the phases of Venus. We are looking for other worlds through a new lens. This new result is based on transits, events in which the passage of a planet in front of a star blocks some of the star-ass light and produces a characteristic dip. Astronomers using both ground-based and space-based telescopes, like those on NASA's Kepler and TESS missions, have searched for dips in optical light, electromagnetic radiation humans can see. Enabling the discovery of thousands of planets, Di Stefano and colleagues have instead searched for dips in the brightness of X-rays received from X-ray bright binaries. These luminous systems typically contain a neutron star or black hole pulling in gas from a closely orbiting companion star. The material near the neutron star or black hole becomes superheated and glows in X-rays. Because the region producing bright X-rays is small, a planet passing in front of it could block most or all of the X-rays, making the transit easier to spot because the X-rays can completely disappear. This could allow exoplanets to be detected at much greater distances than current optical light transit studies, which must be able to detect tiny decreases in light, because the planet only blocks a tiny fraction of the star. The team used this method to detect the exoplanet candidate in a binary system called M51ULS1. While this is a very exciting study, more data would be needed to verify the interpretation as an extragalactic exoplanet. One challenge is that the planet candidate's large orbit means it would not cross in front of its binary partner again for about 70 years, thwarting any attempts for a confirming observation for decades. Unfortunately, to confirm that we're seeing a planet, we would likely have to wait decades to see another transit, and because of the uncertainties about how long it takes to orbit, we wouldn't know exactly when to look, said co-author Naya Imera of the University of California at Santa Cruz. Another challenge is that one might expect clouds of gas and dust to absorb X-rays more than a solid body like a planet. Could this dimming have been caused by a cloud of gas and dust passing in front of the X-ray source? The researchers consider this to be an unlikely explanation, as the characteristics of the event observed in M51ULS1 are not consistent with the passage of such a cloud. The model of a planet candidate is, however, consistent with the data. We know we are making an exciting and bold claim, so we expect that other astronomers will look at it very carefully, said co-author Julia Bernson of Princeton University in New Jersey. We think we have a strong argument, and this process is how science works. The authors will search the archives of both Chandra and XMM Newton for more exoplanet candidates in other galaxies. Substantial Chandra datasets are available for at least 20 galaxies, including some, like M31 and M33, that are much closer than M51, allowing shorter transits to be detectable. Another interesting line of research is to search for X-ray transits in Milky Way X-ray sources to discover new planets in unusual environments. If a planet exists in this system, it likely had a tumultuous history and violent past. An exoplanet in the system would have had to survive a supernova explosion that created the neutron star or black hole. The future may also be dangerous. At some point, the companion star could also explode as a supernova and blast the planet once again with extremely high levels of radiation. Interestingly, studying exoplanets in different systems helps us understand our own solar system better. By observing a variety of planetary systems, astronomers can learn about the formation and evolution of planets and their host stars. They can also study how planets interact with their stellar environment, such as the weather and climate on exoplanets and whether they have atmospheres. Furthermore, studying exoplanets allows us to search for habitable worlds and potentially discover signs of life elsewhere in the universe. By understanding the conditions that make a planet habitable, astronomers can better understand the unique factors that make Earth suitable for life. While there's no guarantee that we'll find life elsewhere in the universe, the search for exoplanets is an essential step in this quest. Ultimately, studying exoplanets helps us understand our place in the universe and the possibility of life elsewhere in the cosmos. There are several ongoing projects searching for exoplanets, including the Transiting Exoplanet Survey satellite tests and the James Webb Space Telescope (JWST). These missions are expected to discover thousands of new exoplanets in the coming years. In addition, astronomers are developing new technologies and techniques to detect exoplanets, such as direct imaging and gravitational microlensing. Direct imaging involves taking pictures of exoplanets directly, while gravitational microlensing uses the gravitational lensing effect to magnify and detect exoplanets. As we learn more about exoplanets, we can better understand the diversity of planetary systems in the universe and the factors that make our solar system unique. Whether we find planets that are similar to Earth or completely different from anything we can imagine, each discovery brings us closer to understanding the origins of our own planet and the possibility of life elsewhere. In the cosmos, the research described here was conducted under NASA's Chandra Guest Observer program. D. Stefano acknowledges support from NASA's Hubble Fellowship Program and from the Alfred P. Sloan Foundation. The authors thanked the anonymous referee for a thorough and constructive review. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory's Chandra X-ray Center controls science from Cambridge, Massachusetts, and flight operations from Burlington, Massachusetts. So what do you guys think about this incredible news? Do you believe that we may have detected signs of a planet outside of our galaxy? Let me know your thoughts in the comments down below. And if you like this video, don't forget to hit that like button and subscribe for more updates on astronomy and astrophysics.